Hey everybody, today we're going to continue our discussion on normal distribution. So I just want to kind of do a quick recap of what we talked about yesterday, and then I just want to do a couple of practice problems. You have a worksheet today that's got more of these types of problems on it. I just want to make sure that we're all okay with how to do these things. So in front of you, you'll see here, this is the normal curve. You'll see written underneath, these are all of your standard deviations. So remember, right here is your mean. So right here would be your x bar, that's your mean. And then these numbers are the number of standard deviations above and below the mean. You can go up by half a standard deviation as well, so that's what this 0.5 is. That's 1/2 a standard deviation. Then you have 1, and then 1.5, and then 2, 2.5, 3, etc. You'll also see here all of these percentages that are within each of these kind of spots on the curve, and you'll see that they correspond to the percentage of the data that falls within that range. So 19.1% of all of your data is between half a standard deviation below the mean and the mean. Okay, so we'll talk about that a little bit more as well. One other thing I want to talk about is percentiles. So we started talking about that yesterday, and a percentile is just sort of a measure of how a piece of data compares to the whole population of data and where it falls within that population of data. If this is our mean right here, then this would be our lowest point, right? And so as we look at this from left to right, we're actually increasing our percentile. And the way you can figure it out is simply by adding up these percentages. So for example, if I were to add up all of these percentages below the mean, so if I added them up, I would have 0.1 plus 0.5 plus 1.7 plus 4.4 plus 9.2 plus 15 plus 19.1. And if you add all those up, that adds up to 50. So 50% of your data, 50% of your data is below the mean, 50% of your data is above the mean. So all of these percentages that you see here add up to 100%. Okay, so if you're talking about a certain percentile, you can add up your percentages to see what that percentile is in relation to the standard deviation. Let me explain to you what I mean by that. If I were to add up 0.1 plus 0.5 plus 1.7 plus 4.4. So actually I'll go to plus 9.2. I'll add up all of those. So I'm adding up all of these from here down. I'm going to add up all of those percentages. Okay, that's what I'm adding up here. So if I add all those up, I'll do that on my calculator. 0.1 plus 0.5 plus 1.7 plus 4.4 plus 9.2. If I add all those up, that adds up to 15.9, right? And that has a 15.9, which is about 16%, right? Roughly 16%. So one standard deviation below the mean is equivalent to the 16th percentile of your data. Okay, let me say that one more time. One standard deviation below the mean is equivalent to the 16th percentile of your data. When you're talking about percentiles, you're always starting from the left and adding to that. Okay, you're always adding to that. So if I added another 15% to that, so if I added another 15%, that would give me 31%. So right here at half a standard deviation below my mean, I'm at the 31st percentile. When I'm at my mean, I'm at the 50th percentile. Remember, percentile is the percent of data at or below that value. Okay, at or below that value. That's what percentile means. So at the mean, 50%, that's your 50th percentile because 50% of the data is at or below that amount. As you go past the mean, your percentile increases. So when you get all the way up here to 3 standard deviations above the mean, you're basically in the 100th percentile because all of the data falls below that value. Okay, so you want to kind of read this from left to right when you're thinking about percentiles. We're going to do a few examples so you can get an idea of what we're talking about here. It says a set of data has a normal distribution with a mean of 5.1. Okay, so here's my curve. Here's my mean. This is 5.1 right here. That's my x bar. Squeeze that in there. That's x bar. Standard deviation of 0.9. So if I go one standard deviation above my mean, I'm going to add 0.9 to that. That puts me at 6. Let me clear this off and start that again. So this is my x bar right here. And this was 5.1. My standard deviation is 0.9. So this would be at 6.0. 2 standard deviations above my mean would be 6.9. 3 standard deviations above my mean, if I added 0.9 again, that would put me at 7.8. Okay, if I go below my mean, so 1 standard deviation below my mean, I'm going to subtract 0.9 from that. That would put me at 4.2. If I go another standard deviation below that, so I'm going to subtract 0.9 from 4.2. That puts me at 3.3. And then if I'm 3 standard deviations below, I'm going to subtract 0.9 from that. That puts me at 2.4. So those are the scores, or the standard deviations and the scores related to them. Okay. Now, this is your normal curve. This is all the data filled in. Okay. It says find the percent of data within each interval. So we have the curve. So what is the percent of data between 6 and 6.9? Well, that's between 1 and 2 standard deviations above the mean. I'm going to go back to my chart. Between 1 and 2 standard deviations above my mean, I'm just going to add the 9.2 and the 4.4. If I add those together, that gives me 13.6. So 13.6% of my data is between 6.0 and 6.9. That doesn't mean percentile, that just means the percent of all of the data. It's 13.6% of all of the data is between 6 and 6.9. Greater than 6.9 would be anything above 2 standard deviations. I'm going to go back to my curve and look at that. So above 2 standard deviations would be this 1.7, 0.5, and 0.1. So if I add those together, that comes out to be 2.3%. So that would be 2.3%. Between 4.2 and 6.0, so that is within 1 standard deviation of the mean on either side. We talked about that yesterday. If you are within 1 standard deviation of the mean, you're adding up these 4 values. That adds up to 68.2%. Okay. Less than 4.2, and we could go through all of these and do that same thing. Less than 4.2 would be everything below, everything below 1 standard deviation. We did that before. That was 16%. That was the first one we did. So less than 4.2 would be 16%, which means 4.2 would be the 16th percentile. Okay, because 16% of the data is at or below that number. Less than 5.1, that's your mean. You know 50% of the data is less than that. And between 4.2 and 5.1, if you go back to your chart, 4.2 and 5.1 is within 1 standard deviation. That's 34.1%. Okay, so that's how you're going to use this curve when you're doing problems like this. In this one, it doesn't give you the chart, but it gives you some information here. It says test scores are normally distributed with a mean of 76 and a standard deviation of 10. So if you draw in your curve, my curves never look all that great, but you get the general idea there. So here is your, here is your mean. And your mean here is 76. Your standard deviation is 10. So at one standard deviation, you're at 86. Two standard deviations, you're at 96. Right? One standard deviation below the mean, you're at 66. Two standard deviations below the mean, you're at 56. Okay? In a group of 230 tests, how many students score above 96? Well, above 96, if you go back to your chart, that's at 2 standard deviations. So at 2 standard deviations is right here. I'm going to add up my percentages that are above that. That's 2.3%. So to do this problem, all I'm going to do is say, all right, well, 2.3% of 230. So if I do that in my calculator, I'm doing 2.3%. 2.3% as a decimal is 0.023. Do times 230. That gives me 5.29. Okay, so 5.29. So how many students score above 96? We can't have 0.29 of a student. So you can say about 5 students. Okay, how many students score below a 66? Well, that's 1 standard deviation below the mean. So if I add up all the percentages that are below 1 standard deviation, that's 16%. So if I go back and do 16% of 230, I'm doing 0.16, because that's how you would write 16% as a decimal, 0.16 times 230. That's going to give me 36.8, so approximately 37 students. Okay? How many students score within 1 standard deviation of the mean? We already know that that's 68.2. So 68.2% of 230. 0.682 times 230, and that gives you about 157 students. Okay, that's how you're going to approach these problems. Sometimes they'll give you something that looks a little bit different, right? They're giving you kind of it's still the same, it's still talking about normal distributions, just a different way of representing the problem. They're telling you in this problem that the shaded area represents approximately 95% of the scores on a standardized test. Okay, approximately 95%. If you look here, if you look at the percentages that are greater than 2 standard deviations away, that's 2.3%. Down here, that's also 2.3%. If you add that up, that's, just a little bit, right? That's 4.6%. So it's about, it's almost 5%. So anything more than 2 standard deviations away, right, is going to account for roughly 5%. What I'm saying is within 2 standard deviations on either side, that's roughly 95% of your data. So these numbers represent within 2 standard deviations of the mean. So if I take the difference of 92 and 78, if I do 92 minus 78, 92 minus 78, that comes out to be a total of 14. Okay, that comes out to be a total of 14. That has to represent 4 standard deviations because that's 2 above and 2 below. So this is 1 below, this is 1 below, here's 1 above, this is 2 below, or this is 2 below, this is 2 above. So if I divide 14, if I divide it by 4, that gives me 3.5. So each standard deviation is 3.5. So if I add 3.5 times 2, if I add 7 to 78, right, that gives me 85. So my mean is at 85.